Hi, I'm Alex, and this video is on Epstein's anomaly. You may be wondering what the heck that is exactly. Well, it is a congenital malformation of the heart that is characterized by apical displacement of the septal and posterior tricuspid valve leaflets, leading to atrialization of the right ventricle, the variable degree of malformation, and displacement of the anterior leaflet. Yes, that was a lot of information. But basically, the host has an enlarged heart because the right side of the heart works properly. This causes the left side to work double time and increase in size. As shown in the picture, the abnormal heart tricuspid valve is abnormally shaped in the tricuspid ventricle, causing it to enlarge. The unaffected portion of the heart grows in order to make room for the right ventricle. Epstein's anomaly, EA for short, cannot just appear out of nowhere. It is a heart defect that you have at birth, congenital. Only genetics can determine whether or not it will occur. Why it occurs is still unknown, but it is still very rare. EA happens early in the development of a baby's heart. It is usually caught in the first few months of growth. In this case, Eric's condition was not fully seen as a problem until he traveled to the cardiologist at 12 months old. The cardiologist then decided that he was to come back every 6 months for checkups. When Eric was a child, people never knew that his heart was abnormal. As he grew up, being a kid was a struggle, since only half of his heart was working properly. The left portion of the muscle swelled and dropped to his stomach, making him appear bloated. When Eric was in middle school, he had bad stamina and breathing troubles, on top of there being more weight added, which often led to him being bullied. His skin alarmingly started to turn blue because the blood did not have oxygen when it went through the heart, leading to it being circled throughout the body again. Around his early 20s, his cardiologist suggested that he travel to the Mayo Clinic in Rochester, Minnesota, that specializes in cardiology. Over the course of his life, being in his early 50s so far, he has had 3 surgeries, once when a pig valve was inserted. Every 10 years, Eric has to go back to replace the previous pig valve. However, some surgeries did not go well, and it had to be replaced after 3 years. At the moment, the only solution for Epstein's anomaly is surgery, and to deal with the problem throughout the course of your life. Recently, an idea of genetically modifying the DNA structure and the instruction has surfaced. CRISPR is a man-made bacteria that can change a DNA sequence and possibly cure multiple diseases. This is also a new way that is being used in multiple labs for new research on mutations. In this case, Epstein's anomaly is passed down throughout the genes. So, if the DNA was changed, the heart defect would not be present. The process of DNA replication in the baby will all stay the same, except this one piece of gene will be modified. Epstein's anomaly is one of many bad mutations because it affects the heart in a way so it cannot work properly. The mutation that many scientists think is involved is MYH7, which happens in chromosome 15. This mutation involves the genetic instructions for a protein known as the beta meiosis heavy chain. This mutation appears in the heart muscle and skeletal fibers. This replacement is involved throughout DNA structure and the double helix. Another factor going into this is the reproductive system, also called meiosis. Meiosis results in 4 daughter cells, which is sexually reproductive. So, if the CRISPR method works on the parents only, fixing the one thing, then the aftermath of meiosis would have a different outcome. In this specific situation, we would use substitution to replace the affected gene. Eric went on to have children of his own, and now since the kids are carriers, I have to decide whether or not to follow up with the CRISPR route, or forever be abstinent. If the family was not to be carried on, it would be mindful to get tested in case for treatment. CRISPR could help a lot of people, though, in this case, since it is so rare, it might not be able to transfer to bigger things like cancer. But to go big, you always should start at the bottom. Thanks for watching. I hope this video inspired you to learn more about CRISPR and those small diseases. Now, go out and change the world.